Right, Assalamualaikum and very good morning to our students. Okay, today we're going to do the briefing about lab number 4, which is a colorimetric test for carbohydrates. Okay, so please be ready with the material that we need for this lab. So please bear in mind, today you are going to do some report about this lab 4. And this lab 4 will be examined and will giving you marks for your assignment for lab. Okay, so please be ready. All right, so formatting for laboratory reports, okay. All right, the lab report must be handwritten, okay, which means that you have to use your hand to write your lab report. Except for your front pages, front pages you can type because we are already giving the example, and then you can use the front pages for lab report. So lab report must be used the front cover given at the end of these instructions, okay. I already put it in the future. Diagrams, tables, and figures must be appropriate labeled. Okay, each student is required to write an individual lab report for each experiment. So which means you have to do by your own. So one report, one students. Okay. So the format of your lab report must be sequenced as listed below. Number 1 will be your title. Number 2, objective. Okay. So title can be the same, objective slightly can be same, but you must have what we call modified from the original one. Okay, introduction. Okay, materials, which is reagent and apparatus. Procedure. So this procedure must be written in the past tense and third person language. Expected result from today's experiment. Okay. Discussion. Okay. So mostly discussion is discuss back all the expected result that you get from each of the tests. Okay. And then last one will be conclusion. So conclusion is whether you agree or not with the objective or what the finding you get from the experiment. Last one will be your reference. Okay. Minimum 3 and not taken from the lab manuals. All right. Make sure you have your own references, and that references must be written with the APA style writing. So please open your Google and check APA style writings all about. Okay. And then to submit the lab reports, take the picture of your lab reports. Okay. Convert the picture to the PDF as one file, and then submit it in our online platform, which is Google Classroom. Okay. I will be giving you the group and the link later on, right? So we go quickly for the front pages for our lab report. Okay, this is your front pages for each of your lab report. So lab report, lab number 4, okay. Okay, already written there, the colorimetric test for carbohydrates. All right, please put your name there, your student ID, and your groups. Okay, so please bear in mind, date of submission is before 4th December 2020. Okay, more than that, it consider not be accepted by me, all right? Now make sure they are not more than 4 December, all right? So the marks will be given according with the objective, okay, titles, introduction. Okay, from here, you will get 2% from that. Experimental procedure, all right, if you follow the guideline, can get full mark from here. Results, is it data, figures, graph, tables, okay? So mainly colorimetric test is for qualitative tests. So make sure you have an idea to do your experiment result, okay? You can check back other experiment that use the result for qualitative tests. Okay, there will be 4 marks and you will get 2% from that. Discussion and conclusion and references. Okay, so these 3 parts will give you 6 marks and will convert it to 2%. So there will be a post-lab question. So where we can find the post-lab question inside your manual. So please answer all the question. You will get 4 marks and we'll convert it into 2%. Right? So total will be 20, and these 20 marks will be converted into 10%. So you will get 10% of lab report from the lab sessions. Okay. Is there any question before we continue to our lab today? Okay, ada soalan sebelum kita sambung mengenai lab hari ni? Ada soalan?
Tak ada, sir.
Alright, so semua faham Okay, make sure awak ada post lab question because that one will give you marks also. Okay, so post lab ni awak tulis selepas daripada discussion, conclusion and references. Alright. Without that, you cannot get the 2% to complete 10%, right? So now we're going to do the briefing about labs. Okay, so please be ready with your manuals. Okay, so today experiment is laboratory number 4, which is colorimetric test for carbohydrates. Okay, so before we start our lab, there will be introduction for your experiment. So what is introduction? Carbohydrate is a class of organic molecules with the general formula CnH2ON in bracket N. So N can refer to any number, 1 until infinity. If we say N1 CH2O in bracket 1 kat luar tu, okay? So N represent the number, okay? Any number you can give, 1 until infinity. The basic carbohydrate units are called monosaccharides. Okay, saccharides mean sugar, monosugars. There are numerous different types of monosaccharides or monosugar which differ in their number of carbon atoms and the arrangement of hydrogen and oxygen atom which is attached at the carbons. So monosaccharides are linked together by the special bond which called glycosidic to form what? Oligosaccharide and polysaccharides. Okay. So several colorimetric tests have been devised to detect members of these biologically significant classes of carbohydrate. Okay, sorry, carbohydrate or compound. This test will utilize a test reagent that yield a color changes. So this one experiment is more on qualitative tests. After reacting with a specific functional group of the compound being tested. The following exercise are reactions that can detect the presence of or absence of carbohydrate. Okay, in the test solutions. Okay, they arrange it specifically or specificity to the very generals. All right, this one have what we call objective. To use the following qualitative tests to distinguish specific sugar from each of other. Okay. So this is objective. You can use or you can modify that from that. Okay, methods. So test 1 is a Benedict test. So the procedure, you have to add 1 ml of sucrose solution to the 1 ml of Benedict reagents. Heat up in a boiling water about 5 minutes or water bath for 5 minutes. And then repeat the same procedures with the glucose. Okay, so the expected result from here, the break rate precipitate indicates a positive test for reducing sugar. Okay. So test 2, Barfoed test. Okay. So we need a 1 ml of sucrose solution and mix with the 1 ml of Barfoed reagents. Heat in a boiling water bath for 10 minutes. The interval time, you have to write down the changes. Interval time dia adalah 3 minit. Okay. Masa di antara 3 minit pertama, 6 minit, 9 minit. Okay. Dan until masa ke-6 dan masa ke-9. To masa ke-10. Right. So you have to repeat this experiment with others monosaccharides, which is glucose and lactose. Okay, other samples with glucose and lactose, right? So expected result from here, you will get a copious amount. Copious mean bahan yang sedikit, alright? Brick red precipitate, which is given you the positive result for reducing monosaccharides. So hydrolysis of disaccharide may lead to the trace of precipitates. Okay. Okay, the third one is Seliwanoff test. Add 1 ml of glucose solution to 1 ml of Seliwanoff test. Heat in boiling water bath for 5 minutes. And then you have to repeat the same procedure with other samples, which is fructose. Okay. So from here, the expected result you can get is a deep red. Once you get the deep red, it shows that you get the sample which is contain ketohexose. Okay, ketohexose. So what is mean hexose? Hexose is 6 carbon ring, and keto is one of the example of monosaccharide for carbohydrate. So we will discuss it on chapter 5 next week, inshallah. So other sugar will give red color upon the prolonged heating. Okay. So the specific test for Seliwanoff is to detect or to find ketohexose only, right? Tapi result lain boleh juga memberikan yang result yang sama juga. Tapi dalam keadaan warna merah saja. If we heat it with a prolonged heating, okay. Test number 4 is Bial test. Okay, we need 1 ml of sucrose solution to 1 ml of Bial reagent. Okay, mix up both of it, and then you have to heat in the boiling water for 2 minutes. Okay, and then repeat the same procedures with the other samples, which is arabinose and glucose. Okay, so indicate the qualitative test result. If you get blue-green color, it indicates or it shows that you have a pentose. If it's yellow-green, it indicates hexose, 6 carbon ring, pentose, 5 carbon ring. And is it yellow? Is it only show you disaccharide? Okay, so this is all example of the positive result. Okay, expected result from the experiment. Okay, and then you scroll down your manual, and then there's a question for you. So there will be marks for 4 questions. Okay, so post that question, you have to add it on your report juga. Okay, so what are the questions that are you going to answer? Number 1, if the sample being tested give a positive result for Benedict test and Barfoed test, then what will the sample be? Okay, so which sample will give you same result, Benedict and Barfoed, right? Name the suitable test to A. Distinguish a pentose and hexose. B. An aldohexose and ketohexose. Okay. Right. Number 3, identify the brick red precipitate in Benedict test. Last one, name the bond involved when disaccharide is hydrolyzed. Okay. Okay, then the question about manual. Is there a question left? Ada soalan tak pasal manual? Faham tak apa dia yang awak kena buat untuk report?
Sir.
Ya. Yeah.
Maksudnya kan, kami kena buat lab 4 ni, tapi semua test yang atas tu kan banyak kan? Semua test tu kami kena buat kan?
Ya betul. Awak kena buat report the lab test tu, ya. Yeah.
Memang semua sampai banyak-banyak tu kan, like bio test semua tu kan?
Ya, betul.
Okay, itu je sir.
Itu je. Alright. Lagi soalan lain ada?
Sir, kalau kan kita ada 4 test kan untuk karbohidrat ni. Lepas tu dia punya material tu nak campurkan semua ke macam asing-asing? Kita macam ikut test dia.
So depending untuk awak lah. So better you all buat asing-asing pun boleh, sekalikan pun boleh. So up to you untuk buat.
Okay,
section
thank you.
Memang, okay, section tu ada markah alright.
Okay sir, nak tanya lagi.
Yeah.
Dia kata buat dalam past tense kan, so maksudnya macam contohnya macam larutan ni dicampurkan macam tu
Yeah, in English, alright. You have to
Okay.
change back the word.
Alright, sir.
Has been, okay. Are been, okay, sorry, apa? Pipetted, okay. So ulang balik perkataan tu kepada past tense, right?
Okay, sir. Thank you.
Lepas tu sir, apa ni, dia punya result tu, kita nak tulis result dia sekali ke macam kosong kan?
Result kena ada lah, expected result sebab tu ada markah.
Oh, okay. Thank you sir.
Okay. So example for past tense, heated, okay, heated in boiled water, heated. Tambah ed kat situ, repeated ed tu alright? Tense. Okay, any other question? Before we going to know about summarize of the experiment. Soalan lagi tak?
Sir,
Right.
untuk apparatus dengan reagent tu boleh campur ke tak kisah asing-asing?
Apparatus untuk eksperimen. Apparatus tu lah. Boleh, sama boleh campur boleh.
Campur dengan reagent.
Yep, boleh.
Okay, terima kasih sir.
Oh, maksudnya campur sekali untuk semua test and then asing-asing test kan, sir?
Ya, betul. So awak rangkumkan satu material and method, material tu rangkumkan semua, apa solution, apa tools, semua tu. Lepas tu awak buatlah test-test tu. So dalam test tu awak buatlah manual saja, okay. Protocol, procedure, right?
Okay, thank you, sir.
Okay. Lagi ada? So please make a report as creative as you can. Okay. So some will put it inside the table, someone in paragraph, ikut awak lah mana satu. Okay. So make simple and creative as you can.
Sir,
Yeah.
untuk objektif dengan intro ni kan, kita boleh ambil daripada lab manual je ke? Tak boleh
Semua yang ada dekat manual tidak boleh diambil balik. You have to
Okay.
modify.
Thank you,
Modified Itu saya bagi hint Kalau tak markah tak ada. Okay, any question left? Ada soalan lagi?
Sir, kalau yang intro dengan intro dengan objektif tu kita modify tapi dia macam tak ada beza sangat. Maksudnya macam kita modify tu sikit je. Still kena, tak boleh lah.
Lain daripada manual. Itu je.
Oh, okay.
Okay, think about it. Okay, others? Ada soalan lagi? Other questions so far?
Tak ada kot.
Alright, so we continue for our summarize about the experiment. Okay. Alright, so we go for the summarize of the experiment. Okay, laboratory number 4, colorimetric test for carbohydrates. So this one is also available in your future course content, so you can download it and help you on writing the report. Okay. Alright, so objective. Okay, to use the following quantitative tests to distinguish specific sugar from each other. Okay. Alright, the principle behind the experiment. Okay, so before that, you have to know about a carbohydrate. So carbohydrate are the polyhydroxyaldehyde and ketone, or substance that hydrolyze to yield polyhydroxyaldehyde and ketone. Okay, so which means that carbohydrate have two types of substance, which is a ketone and aldehyde. So what is aldehyde and what is ketone? Aldehyde have a CHO, whereas ketone have the carbonyl group, okay, which is constituted in a major group in the carbohydrates. So carbohydrates are mainly divided into monosaccharide, disaccharide, polysaccharide. Monosaccharide means 1, disaccharide means 2 or 3, polysaccharide means lots of more than 3. Okay, the commonly occurring monosaccharide includes glucose, fructose, galactose, and ribose. So this 4 type is only we call monosaccharide. The two monosaccharide combine together to form disaccharide, which is sucrose, lactose, and maltose. Right? So this is example structure of monosaccharides. Okay. For example, this one is a glucose. Okay. All right. The free method number 1 is Benedict test. So the free aldehyde or ketone group in the reducing sugar are reduced what inside the Benedict test. This is a Benedict reagent. This is what we call a cupric hydroxide in alkali medium to get what we call the red color cuprous oxide. Okay, depending on the concentration of the sugar, yellow to green color is developed. All monosaccharides are reducing sugar, as they all have a free reactive carbonyl groups. So what is the carbonyl group? Awak akan tengok nanti. Some disaccharide like maltose have an exposed carbonyl group and are also a reducing sugar, but less reactive than monosaccharide. So ABC is our procedure for doing this experiment. So observation or expected result, a break rate precipitate indicate a positive test for reducing sugar. So for Benedict test, dia akan menyebabkan perubahan pada cuprous ion, ataupun cuprous oxide. So cupric ke ada dalam kita punya Benedict reagent. Okay. So Benedict reagent akan menyebabkan berlakunya persekitaran alkali. Okay. Alright, continue. Summary, any sugar contain of amino acetals as a reducing sugar. So what is amino acetals? So amino acetal kita akan belajar dalam chapter 6. Okay. So this is example of structure of amino acetals, which is one OH groups or hydroxyl group and one O oxygen with R group. So R group represent the side chain of the group. Ingat lecture semalam, okay, about amino acid, same as process, side chain, attached to the same carbon in the equilibrium with the aldehyde or ketone, right? Okay. So these adalah amino acetals. What are acetals? A 2O R group is a side chain attached to the same carbon and not in equilibrium with aldehyde or ketone, which is locked. Okay, so to detect these two acetal or ketal, we are using several experiment ataupun reagents. There will be Benedict test and failing solution. So Benedict test and failing solution ada bahan lain dalam tu, iaitu dengan sebagai cuprum. So cuprum ni menyebabkan kita dapat warna merah tadi. Okay. Another one will be Tolan test, what we call argentum. So these two things is a reducing agent. Okay. So sugar with the amino acetal is a non-reducing sugar. So for example, is our sucrose. Sucrose is one example of non-reducing sugar. So what is reducing sugar? So sugar is a site of our monosaccharides, which is glucose or fructose, that able to make a bond. So dekat sini kita ada kedudukan OH ni. OH ni yang boleh membolehkan kita membentuk ikatan. So this represent that glucose have one of the example of reducing sugars. So why we need to do Benedict test is very important for quantifying blood glucose. Okay, because of what? Cuprum akan react dengan kita punya glucose dalam darah, menyebabkan kita dapat warna merah tadi. Right? Untuk pesakit-pesakit yang ada diabetes dan sebagainya. Okay, we go for the Barfoed test. Barfoed test is used to detect presence of monosaccharide, which is have the reducing sugar in solutions. So what inside Barfoed reagent? A mixture of ethanoic acetic acid and copper 2 acetate. Okay, again we have a copper. Is combined with the test solution and boiled. The red copper 2 oxide precipitate is formed with indicates the presence of reducing sugar. The reaction will be negative in the presence of disaccharide sugar because they are weaker reducing agent. This test is specific for monosaccharides. Okay, so untuk kita dapatkan monosaccharide, yang paling sensitif test kita pakai Barfoed test. Due to the weakly acidic nature of Barfoed reagent, it is reduced only by the monosaccharide. Okay, so A, B, C, D is the same procedure inside your manuals. Okay, so what expected result you get from here, observations, and copious amount of break rate precipitate indicates a reducing monosaccharide. Hydrolysis of disaccharide made it to the trace of precipitate. So ada dua konsep Pertama, monosaccharide, awak akan dapat copious amounts of break rate precipitate. If it's using a disaccharide, you will get a trace but too low. That's why we call it lead to the trace. Okay. Alright, Seliwanoff test. Okay, so from picture here, there are what we call aldose and ketose. This is two types of lots inside the carbohydrate. Okay, two types of carbohydrate is aldose and ketose. So what's meaning of carbonyl group? This is a COO. COO is represent the carbonyl groups. Okay, so what happened inside this test? Okay, it is a coloration specific for ketose. So ketose, this one Apa beza antara aldose dan ketose? Kedudukan carbonyl group ataupun COO bond tu. Kalau aldose dia terletak pada hujung kita punya structure. Tapi untuk ketose terletak pada structure di tengah-tengah. So this example of structure ataupun projection of Fisher. So kita akan belajar minggu depan what is the meaning of Fisher projection. Okay. When the concentration of the hydrochloric acid is added, ketose undergo dehydrate to yield fulfuril derivative more rapidly than aldose. Okay, so ketose ni akan membentuk satu bahan dikenali sebagai fulfuril. Okay, these derivatives form complex with resisonol to yield deep red. So, fulfuril derivative yang bergabung dengan ketose ni akan bergabung dengan satu lagi bahan untuk memberi pewarnaan dikenali sebagai resosinol. Okay, that's why kita dapat red, deep red color. The test reagent cause the dehydration of ketohexose to form. Okay, apa bahan yang fulfuril yang kita dapat daripada ketose tu dikenali sebagai 5-hydroxymethyl fulfuril. So this 5-hydroxymethyl fulfuril akan react dengan resisonol. Kenapa dia perlu react? Sebab kita dapatkan warna deep red. Okay. So within 2 minutes. Okay. So kita ada ketose, kita ada aldose. So tapi untuk aldose hexose ataupun aldose 6 carbon, react isomer slowly to form the same product. Okay. So A, B, and C is a procedure same as our manual. Okay. So expected result from here, you can get deep red for ketohexose. Ketone 6 carbon ring hexose. So other sugar macam aldose hexose kita dapat juga, tapi kita kena prolong the heating. Kita panaskan dengan lama sedikit. Tapi warna dia bukan deep red lebih kepada reds. Okay. So kenapa berlaku tu? Sebab ketose boleh membentuk fulfuril derivative. Aldose boleh juga bentuk, tapi kedudukannya membezakan bentuk fulfuril tu. Okay. So once ketose membentuk fulfuril derivative, dikira sebagai 5-hydromethyl fulfuril. So this 5-hydromethyl fulfuril akan bergabung dengan resisinol dalam kita punya Seliwanoff solution tu dan membentuk warna merah. Okay. Deep red, merah gelap. Okay. Okay, Barfoed test is used to detect presence of monosaccharide reducing sugar in solutions. Okay. Barfoed reagent, apa dalam Barfoed ada? Is a mixture of number 4, method number 4 is Bial test. Okay, Bial test is used to distinguish between pentose and hexose. So pentose is 5 carbon ring, hexose is 6 carbon ring. They are react with the Bial reagent and are converted to again the same sample fulfuril. Tapi dalam method 4 Bial test ni kita ada pakai bukan resosinol, kita pakai osinol. So osinol akan bergabung dengan fulfuril yang terbentuk daripada pentose dan juga hexose. Okay, and giving you different kind of color because of another present bahan iaitu ferric ions. Okay, osinol and fulfuril condense and present of ferric ions. So bila berlaku 3 bahan ni bergabung, kita akan dapat banyak color bergantung kepada sampel yang kita buat. For example, appearance of green color or precipitate indicate the presence of pentose and formation of muddy brown precipitate show the presence of hexose. Okay. So bila gabungan antara oxinol dengan furfural dan juga ferric ion tu bergantung kepada struktur yang terdapat, tu yang kita dapat warna, yang lain-lain okay. Alright. So oxinol dengan furfural ni kena gabung. Dan dia akan memberikan pewarnaan kepada ferric ion. So ferric ion boleh jadi hijau, boleh jadi biru dan juga boleh jadi yellow. Okay. So A, B, C is our manual. Okay. So expected result, if you get pentose, you will get blue-green color. Yellow-green, you will get hexose. Whereas yellow only, you will get disaccharide. Okay, there are YouTube for you to see. Okay, there's a lot of video inside the YouTube. Okay, awak tengok semua kerja-kerja daripada awak punya senior, AS116 and AS114. Right? Micro. Okay, again, the questions, same as your manuals. Okay, so please answer each of the questions. Okay, you will get 4 marks from that. Okay. Okay, formatting of the laboratory reports. So, ada dekat sini juga. So, awak boleh tengok. Okay. Alright, so they are what we call, again, experiment from Amrita Labs. So, you can see from here there also. Alright, so that's all for your lab report briefing today. Is there any question left for you before I leave you for another 1 hour to do your do your reports?
Sir,
Yep.
yang bahagian reference tu, kalau ambil daripada